Case 2 for the evaluation of the integral of the powers of tangents and secants, or cotangents and cosecants, is when the secants or cosecants have even exponents greater than 2. So let's write that. Even exponents of secant u or cosecant u that is greater or that are greater than 2. So what we want to do here is we want to factor out secant squared u or cosecant squared u. Okay, factor out secant squared u or cosecant squared u. Why? Because we want to perform integration by simple substitution. So this factored out secant squared u or cosecant squared u will be part of our du when we perform substitution. So for example, we want to evaluate the integral. Okay, we want to evaluate the integral of tangent of x to the power of, okay, let's make it 5. Secant, let's say for example, squared x dx. So if the exponent is already 2, then we'll just let u equals tangent x and then perform simple substitution. But if it's already greater than 2, it's even greater than 2, so the next even exponent that's higher is 4. What we will do is factor out secant squared x. So we don't touch tangent, that's tangent to the power of 5x, and then subtract 2 from the exponent. So that's secant squared x, and then we factor out secant squared x dx. So this factored out secant squared x is already part of our du. So if this is our du, secant squared x dx is our du, then the rest of the functions here in the integrand must be expressed in terms of tangent. Now, this is already tangent here, x to the power of 5. We have to express secant squared x in terms of tangent, and we are going to use the Pythagorean identity. So what's the Pythagorean identity for that? That's tangent of x to the power of 5, and then secant squared x is equal to tangent squared x plus 1. And we have secant squared x dx. So we can now let u equals tangent of x, so that du equals secant squared x dx. So substituting, tangent x to the power of 5 is equal to u to the power of 5. Tangent squared x is u squared plus 1. And secant squared x dx is equal to du. Then we distribute, so that would be u to the power of 7 plus u to the power of 5 du. And then we proceed to evaluating the integral. That's u to the power of 8 over 8 plus u to the power of 6 over 6 plus c. And then go back to the original variable, tangent to the power of 8x over 8 plus tangent to the power of 6x over 6 plus c.